Thank you for choosing to watch this Scratch tutorial from D. Aiken Limited. This tutorial starts with the assumption that you have already set up an account in Scratch. The purpose of this tutorial is to give you an overview of the layout and main features of the online version of Scratch. If you are using an installed version of Scratch on your computer, then everything mentioned in this tutorial is broadly similar, and therefore this tutorial will work for you. This is the online Scratch interface, and as you can see, the interface is split into four main areas. Let's look at them individually. In the first area here in the top left of the screen, this is called the stage. This is where your coding will either do as you intended or not. In other words, the stage will be the place where you can evaluate the effectiveness of your computational thinking, where you'll get immediate feedback on the accuracy of your pattern matching strategies or your abstraction strategies as you write your coding algorithms. Below the stage is the area where you will add and work on your sprites. Each sprite is an actor or a character or a function in Scratch, and it is here that you will select each sprite and then write the appropriate code for their individual and collaborative performances on your stage. Note, there is a blue highlight line around the current sprite you are working on this area, so it's easy to select and identify which sprite you are wanting to work on, simply by clicking on it to select it. A subset of the sprites is the stage itself. The stage sits to the left of the sprites, and again, if you wish to work on it, it can be easily selected by simply clicking on it. It is possible to have several stages, and if we look at the Backdrops tab here, in a Scratch project, and these stages can be considered levels if you are wanting to create a game in Scratch. To the right of the stage and the sprite area is the major working area of Scratch. This central column is separated into three tabs. The default tab is the Scripts tab, and it is here that you can select from all of the color-coded script blocks to create your project outcome, and we will look at these in a moment. The second tab is the Costume tab. And using this tab will allow you to create your own sprite to add to your Scratch project, and again we will look at this in more detail in a moment. The final tab in this section is the Sounds tab, and here it's possible to assign sounds or to record sounds relative to a specific sprite, and once again we will look at that in more detail later. The final area and the largest area of Scratch is this right hand area. And this area, depending on what tab from the central area has been clicked on, is the main working area of Scratch. And under this default Scripts tab here, this is the area where you will spend most of your time building and testing your code. We just simply drag our blocks out into this main area here, and we'll look at this again in more detail in a moment. Okay, let's jump back to the left hand side of the screen and start to look at some of the sprite controls on offer to us. Oscar here is the default Scratch sprite. And as you can see, in relation to the rest of the stage, he is quite large. We can alter the size of Oscar or any sprite we choose by selecting either of these two buttons. The shrink button, when selected, will progressively shrink a sprite on each mouse click. To stop the shrinking, simply click in any white area, and then to reverse the process, click on the grow button and click back on the sprite, and you can grow back in size again. So it's really useful to scale your sprite to the size of your project. The other tools of note here are the duplicate button, which if you duplicate, it will duplicate your scripts as well as your sprite, and the delete button will obviously just delete the entire sprite. There, gone. Moving down to the sprite area, let's take some time to look at the features available to us for each sprite. Once a sprite has been highlighted, the I for Information button appears. Here we can see that we can change the name of the sprite, this can be a good idea if you've got many sprites looking the same size. We can look at its XY position, which is good to help us position it on the stage, and as we move the sprite around the screen you can see what its XY and position is, which is useful for locating things. And over here we can look at the direction button, and if we rotate this handle we can actually change the direction in which our sprite is pointing. And if you have executed a program and your sprite ends up pointing in this direction, then you come into here and click on this handle and you can move your sprite back to the position you want it to be in. Then here we've got the rotation styles, and when we get to creating our own sprites, finding the center of rotation and then using these different rotation style points is useful for depending on how you want to make your sprite rotate in your game. And finally, down the bottom here, we've got the show button. Now obviously by default it is clicked, but if you want to actually have your sprite disappear until a certain point in the game, or you just want to hide it while you're working on other points, you can just click on here and show or hide the sprite. And to get back to the sprite and the main sprite bay, you click on this back arrow. Now it's time to start making our first project. And the first thing I want to do is to delete Oscar. On a PC this is a simple right click function. On a Mac it's shift and click. And we can just click on delete. Scratch has a large selection of ready-made sprites to choose from, and you can browse from here. And you can just go look through all these options here. And once you see something that you like, let's click on fantasy here. Let's say we like this hippo here. Click on that. Once you like the one you want, just click OK, and that's now added to your stage. It is also possible to upload images from your computer to Scratch, and to do that just click on the upload button. You can even capture images from your computer webcam if you want to and use these as a sprite. And this is all pretty self-explanatory. If you want to create your own sprite, click on the paintbrush icon here. In this space you have a range of simple tools that can be used to create your sprite, and it is worth spending a little time here working out what can be created with the tools available. I'm going to make a simple sprite here. I'm just going to make a circle. This could be the start of a Pac-Man. Just click on the yellow icon here and I'm going to click on the bucket. There we are. And as you can see, as I'm creating this, it's being built on the stage here. If we click on the stage, we have the same options. We can click on a backdrop here. We can select a backdrop. So let's select this one and click OK. We can edit as we can any sprite. If we come up to here and say don't like the colour of those walls being green, I wanted to make them, I don't know, let's choose orange. I can use the fill tool here and now I can fill the walls. So let's have a look at this. There you go. And I can make the carpet red. There we go. So I can completely change each sprite if I wanted to. And again, we have these other options here. We can use the paint tool here to make our own background if we want to. We can click on upload and we can even grab pictures from the webcam. Okay, it really is time for us to start to take a look at the main purpose of Scratch and to create projects that run on the code we have created. So let's click on the scripts option here and make sure we've selected the object that we want to work on. I'm going to delete this. Click on here, click on delete. Code can be assigned to a stage. Click on here. We can add our own code to the stage and are assigned to each individual sprite. And the amount of code you add to each sprite and to stages depends on the complexity of the project. So let's take a look at the scripts. Remember to select the sprite that you want to work on and then click on the scripts tab in the central column. And that brings us back to this here. First, let's have a look at how blocks work. Script blocks have been organised into similar and colour-coded actions to make it easier for you to find the blocks you need to make your project work. So let's take a look at them. The blue motion blocks here all deal with movement, turning, rotation, etc. Again, it's worth spending a little time in each of these blocks to see what each colour block is available to you and what they can do. So if we just go down through this, we have the looks blocks and we can say hello and think and all this kind of stuff here, switch costumes, and this is all to do with changing the way things happen on the page. Sound is pretty obvious, not so many blocks here. Pen, again, this allows you to draw. Data, this is really interesting here, there's no blocks here, you make these are the variable blocks. We'll move past the more blocks at the moment. We'll look at operators. This allows us to do maths functions. Sensing, this is all about what is the object in the page here, looking at, seeing, touching, etc, etc. Control, this gives us a whole bunch of really good exciting options here. And finally events. Okay, so now it's time to think about how to go about making the codes work. Scratch blocks are a bit like Lego in that they fit together in certain ways and not in others. For example, if we pull out a range of these blocks, let's just pull these out. I'm just going to click on any of these things, just pull them out. Just some operators going on here. And grab some of these, grab some motion blocks, pull these out. Yep, that should be fine. Note how Scratch will allow certain blocks to fit together. So look at this one here. If we click on this one here, can you see how when two blocks are going to fit together, a white line appears and they seem to click together. If I try and do it the other way around, it won't fit. So if I try, for example, this hexagonal block here, this won't fit here. So some of these blocks don't seem to fit together. But if you look more closely, then we can look at the shapes. So for example, if I pull out a control block over here and click on this one here, you can see that in this space here there is a hexagon shape. So any hexagon shaped block can be put inside it. Click on that. So that works, and this works. But it gets really interesting in Scratch when you can actually start putting blocks inside blocks. So I could put, for example, this block inside here. Obviously it's missing one here. And then I could put this whole block inside that one there. And so as you get more comfortable with Scratch, you can start to make things look really complicated. So I could, for example, put this step inside here. I could put this step inside here, and then I could put this whole block inside here like this. Events blocks, however, these ones here with the rounded tops, are very special blocks, as they are mostly starting blocks, and we use these at the top of our scripts, and if they have rounded top, it means that no other script block can be added on top of them, like this, as I showed you earlier on. Okay, so let's start to build our first script. When working on a project, it's a good idea to have already worked out what it is you're trying to create, and to know or have a good idea about what your end project should look like. And this process is called computational thinking, and my other resources will explain this in more detail. A Scratch project is one large project made up of lots of smaller problems that once solved all combine to make the project. For example, I want to make my circle move, and so to do this I need an events block and a motion block. So I'm going to put all these away, get rid of these, and just move. You want to delete stuff, you just move them out to the side here and they get gone. So this is my event block I want. I'm going to click this one, yes, when clicked, and I'm going to use a motion block, and I click on here like that. So as I click these blocks together, I can see and read them as a sentence, and like all good sentences, it should make sense. If it does not make sense in Scratch, then your script will either fail or not do what you wanted it to do. So get used to reading your scripts and make sure that it makes logical sense. So if we look at this, it says when green flag is clicked, move 10 steps. So I'm going to click on the green flag, and you can see it moves. And to make it keep moving, I've got to keep clicking on the green flag. I wanted this circle to move in a defined way, and not every time I just click the green flag. I can now start to add other blocks to my script to make this happen. I'm going to add another motion block and a control block. So I'm going to click on turn, and I'm going to click on the control block here and click on forever. So what I want to do now is I'm going to change this. I can click inside here and change that to 90. I can click these inside here, and now I've made this new block. So before I click the green flag, I want to show you how to copy these blocks of code, and it's a very useful trick because as your code gets bigger and longer, sometimes you don't want to keep dragging the blocks out. So again, if I just right click on here, I can click on duplicate and bring that out. So if you've got blocks of code, click on duplicate and bring it out. And it's also quite useful, for example, if I added another sprite, let's just say I wanted to add the bat here, and click OK, and I wanted it to do a similar sort of script. What I can do is, you can see in the script function here for the bat there's nothing, and I wanted to pass that on. I can just drag that over the top of the bat, and now if I go to the bat, my script is already in there for you, which is another neat little shortcut. I'm going to delete this guy though, I don't want it. And I'm going to come back to here, and I'll just drag these into the center and get rid of those. I only want one. Now let's watch what happens when I click this green flag. So just oops, just move it down here. Click on the green flag. Okay, Now, because I've chosen the forever option here, it will keep doing this forever. And you can see that the script is running. We've got this yellow highlight round all the way around it, which is great for debugging. So to stop the script, what I've done here is I've created a loop. And to stop the script, I need to click on the stop button. And my script will stop. Well, this is a very simple overview of Scratch. I have plenty of computational thinking activities using Scratch on my website, thelearning.zone, where you can challenge yourself to some computational thinking challenges. And I hope you will join us over there. Good luck.